actually finished her undergraduate degree from Amity University. So some of you might remember that. So with that introduction, I'll get into the background. The background for skin cancer is that we know it's a dangerous disease. It becomes aggressive. And that can be categorized typically in two parts. There's a melanoma and non-melanoma. Non-melanoma are growths which are not really dangerous. Melanomas are dangerous. And this is very aggressive, as I mentioned earlier, and can be fatal. So the question is how fast we can detect it. And the malignant melanomas need to be detected as soon as possible. Typically, it is done by the human. The doctors will look at it and decide whether you have some trace of it. Then later on, they can do other experiments on that. But it's quite often is the case that they misdiagnose. And the misdiagnose could be more difficult to deal with as the disease grows fast. So the question is, can machine do help? And at this point in time, we understand that machine learning techniques have been becoming much better with image and image recognition systems. And AI is playing a major role in that. So the question we ask ourselves is that how do we use that and make it more robust? So I'm not going to claim that we are the first one who are trying to do this. People have tried to do this machine learning techniques to detect melanoma. What we are trying to do is to make it more robust and reliable, and so avoiding the delayed diagnosis. So after having talked about the need for automation and effective solutions, I'm going to get into details of our motivation for doing these things. As mentioned earlier, manual diagnosis is subjective. Therefore, an expert can do it much better than otherwise. And without that expertise, it could be time-consuming. So the question is, how do we deploy deep learning techniques, which are image-based diagnosis for melanoma? And then how do we make it more reliable? So when we studied and looked at the models which were being developed, the general observation is they do a pretty good job. That they can detect in up to 90% cases, depending on the situation. And the question is, how do you go from that 90% to beyond 90%? So as you realize, getting from 1 to 2 is easy, 2 to 4 is easy, and up to 90% is now available. Making it 90 to 95% is the task in hand. And making that reliable is the most important part of it. And part of the reason is that the models generally which are used are either overfitting or use a poor generalization across different data sets. So we try to experiment in a different way. And our approach essentially is that can we take an ensemble of machine learning models, which are guided by the deep features embeddings, and improve the accuracy and robustness. So we are still following the similar methods as other researchers have done it, but we are going to use a combination of them along with the fault tolerance techniques and see whether we can enhance accuracy and robustness. So remember that. So our objective then becomes that can an ensemble-based classification system can be developed, and how do we use these embeddings? So what you will see in the rest of the work is that first we will use a multiple of these models from the machine learning, and we will take multiple deep learning models, which creates the feature space for the machine learning, and evaluate the performance of these models together to get the average result for the ensemble. Our goal will be to be more effective, robust, and general. And we'll try to assess that and show how effective we are. And then the system will be shown as more accurate, efficient, and scalable. So just to give you some flavor of it, what typically is done is that you take a skin lesion image. So there's an image here on the left side shown. You use some image enhancement techniques, and then you feed them to a deep learning model, get the features, and then feed that using the machine learning for the decision making. So image enhancement, deep learning models, and machine learning combinations are used in this particular method. The challenge with this particular paper, the reference given below, is that they don't talk about the inference times or memory uses, so how expensive it is. So of course, we want to do this job. We also want to do it more reliably and accurately, but we also want to do it fast and with smaller memory uses. So those becomes our trade-off features here. The second paper, which I'm going to refer to, is also similar. What they do is that they also take the original image and do the image enhancement method. So they will get an enhanced image, but now they also have a model of it. So this becomes a model-based image processing. So they look for the model and look for the equivalent of that model in different size, shape. So it could be a rotation, a translation of some sort, and still use then the learning model, which is then sent for the classification map. Again, the performance piece has not been discussed in this particular paper from 2022. A third work done, which we have counted on, is that they do their image processing, pre-processing differently. They use genetic algorithms to sensitize detect the hyperparameters, sensitive hyperparameters, and again use the pre-trained models using a different kind of machine learning technique, but they do employ similar kind of voting scheme. So they use more than one model to figure out what the right solution is. The question here was there was no end-to-end learning, and that was something piece missing here. And the fourth model built on the third model, which took several models which were trained, and then trained models were used for decision-making process. The challenge with this particular thing was it was very expensive to compute. So the question was, can we make better use of the similar combination of things, but how to and get them more accuracy and so on and so forth. So essentially our contribution in this work is that we develop a reliable approach which actually enhances accuracy, as we'll talk about it. But we use multiple pre-trained data learning models, and particularly focus on three of them: ResNet 50, VGG19, and EfficientNet. These are well-known models, so I'm not going to go into much details of that. I'll give you a one-slide explanation of that a little later. And we combine them to generate the high quality, because the models are pre-trained, we can use them to generate the high quality flattened features which will be used for our processing. And then we will going to take these models and evaluate on 5 machine learning models. So the 5 machine learning models we use are also standard machine learning models: KNN, logistic regression, XGBoost, random forest, and the SVM, state vector machine model. I'm going to give you one slide version of the description of them as well afterwards, but you can read them about them in the literature later on. So our goal now is that we take this combination of things which are all existing, and therefore we don't need to worry about training them much, and then see what we can do with them to improve the accuracy of the application in hand. So general framework becomes that we take the data set, which includes the benign melanoma images and the malignant melanoma images. So that makes our input combination here. We do the pre-processing on these images, which is the same things which are done by others: resizing, color, format, transformation, and things like that. And then we take these pre-trained models and feed them into we take the pre-processed image and feed them into a pre-trained deep learning algorithms, which gives us the feature extraction. And as we said, we'll use these 3: ResNet 50, VGG19, and Efficient B0. We take these 1D flattened vectors and feed them into our ensemble machine learning models, the 5 of them I talked about earlier. And then we deploy this fault tolerance technique, which is basically voting. So we look at these 5 and then decide what is the correct output. Now, although the voting generally could mean majority voting, But here you can employ more than one kind of techniques in voting. You might give preference to some algorithms output more than others, and that is called weighted voting. You may try that as well here. And then we'll show you some results on how these algorithms perform by showing the performance result. So the framework is pretty simple. The data sets are taken from available literature. Pre-processing algorithms are standard. The feature extraction models we use are also pre-trained. So we save on computing times here. And then we take and work with the pre-trained machine learning models and try to get the output. And we show that it becomes effective. So once you get the feature set, you're feeding them into the machine learning algorithms. So these are the classification model. In this case, our interest is to find out whether it's benign or not benign. It's malignant. So the output will be of the nature or the binary nature. It will be either a 1 or a 0. 1 means it's malignant, 0 means it's non-malignant. If majority of them says it's malignant, then it can be concluded as malignant. When majority of them say it's not benign, then we'll say it's benign. The question we ask ourselves is what is more important if we are not able to conclude positively. So if it's malignant and we say malignant, that's good thing. If it says it's benign and we say benign, it is good thing. The question we ask ourselves, if it's benign, should we be declaring it malignant if we are making an error? That we are not trying to do it intentionally if it happens to be the case that our voting algorithm failed. Or if it is malignant, we call it benign. There's implications of that. If it's malignant and you call it benign, that means you are given a false hope to the patients, and then they will not do any further investigation, and that would be a problem. If it's a benign and you declare it malignant, that will cause anxiety, and the patient will be worried. But the good news with that is that they will do further investigation, and it may turn out it is not. That would be good news later on. So declaring malignant as benign is much worse than declaring benign as malignant. These terms are used as false positive or false negative. False positive, so you are saying it is malignant, whereas it is not. False negative is that it is malignant and we are calling it benign. So focus will also be on the on false negative, that we want to be cognizant of fact that we should allow further investigation. And I'm going to use that as a performance metric as we go forward. So when we start implementing it, of course, the resizing is a standard technique. You try to take an image of different size and try to convert them into a standard size image which your model can process. So typical images the resizing is done on 128 by 128, whereas the input might be 224 by 224. So there's standard methods to do that conversion. You can read them about them in literature. The second thing which happens on the image processing is the color transformation. So we try to standardize the color so that all colors look alike irrespective of where they come from in the standard form. So relatively they look similar, but they are represented correctly. So for example, instead of BZR, you will be in RGB format. And then third technique which is used in the image pre-processing is called data augmentation, which is the balancing the data. The idea is that you want to keep the data and the similar nature, so their rotations, their height, weight shifts, their horizontal flips or flips along the vertical axis and all can be handled. So whenever you get input, you try to get variations of them to try to use your samples from all types of data to make the algorithm more robust with that. So we used all of these three pre-processing methods and then in our implementation here. Now, where do we get our input? We have the data set. So we are looking at the images, which are a combination of benign and malignant. And this table gives you the distribution of the data we are using here. So we used about 10,000 images for training purposes and about 1,000 images for the testing purposes. So we try to keep the benign and malignant image sets roughly equal size. So the data set we used has about 5,000 benign images and 4,600 malignant images. And the test images come from both sides equally to see that the algorithms developed work well on that. So that gives us the data set. Now we take this data set and are going to work with the deep learning models. So I mentioned earlier that we are using 3 of them here. So ResNet 50 is a model which is actually pre-trained on ImageNet. It has 50 layers, residual connections. The main features of this is that it extracts very rich and detailed hierarchical features. Therefore, it's very well suited for the complex images. So it works very well with the complex images, and therefore this has some discrimination power which will not be available in others. So it's actually helps in learning more abstract and discriminative features here. The second set we are working with is VGG19. A second algorithm we're working with VGG19. This is also pre-trained on ImageNet, same input, but it only has 19 layers, and it is more suitable for fine-grained medical image classification. And the last algorithm we use is EfficientNet B0. This is a small variant of EfficientNet family, so there are multiple versions of that. This is pre-trained for speed and memory. So if you look at the 3 DL models, they have been optimized for different regions. Therefore, the features you will expect from them to come out will have different characteristics. And what we are trying to do here is to use all the 3 feature sets, see how effective we can be in doing the task in hand. So some of the characteristics of the feature set is shown here. So the ResNet 50, it takes the image and creates 1D flattened features. And it will take 128 by 128 input and create 4 times 4 times 2048 features. So effectively, the features vector size is 32,000 in our binary terminology. It's 32K. VGG19, on the other hand, also produces the 1D flattened features. It takes the 128 by 128 image, but only produces a feature map of 4 by 4 by 512. So its feature vector set is only 8K. So you see the vast difference between the feature size set between the ResNet and VGG19. And the third one, EfficientNet B0, produces the 1D flattened features. Again, it takes the same thing, but its feature size space is only 4 by 4 by 1280. So it produces 20K. So as you notice here, the feature space is different for each one of these deep learning model. If you use only one of them, you will get one set of characteristics, which will give you certain set of output, and that performs reasonably well, but not as well as a combination can do. That was the conjecture we had. So when we try to do with this conjecture, we will take this feature set and work with these 5 machine learning models. So again, one line description of these models here. The K nearest neighbor among the suggested neighbors. Logistic model that has class probabilities using a logistic function. XGBoost is an efficient gradient boost framework known for its high performance and speed. Support vector machine model is find the optimal hyperplanes to separate classes with maximum margin. So it looks into the vectors differently in a different space. And then the random forest is an ensemble of decision trees that improve accuracy to help reduce overfitting through bagging of the data. So each one of these algorithms has their own characteristics. So we expect them to work differently with the different feature set. And each of the feature set has a different characteristics. So the question then comes back is, how will we perform if we combine them? So we come back with that and implement this. This is where the experimental setup was. And this is just for the completeness in the paper. I'm not going to talk much about it. It basically uses standard Python libraries. And the next question we ask ourselves is, the evaluation parameters. So of course, the most important evaluation parameter is accuracy. which basically says that how many times you give the correct output. Means it was malignant, you said it's malignant, that's true positive. Or if it's not malignant and you said it's not malignant, that's true negative, TN. But then you can have false positive or false negative. So the total number of cases will be either there will be false positive, false negative, true positive, out of which only the true positive or true negative are the correct output. So the ratio of correct output to all outputs is your accuracy. We want accuracy to be high. It cannot be more than 1, so we want to be close to 1. The precision, on the other hand, is saying that how many times you said true positive and how many times you said false positive, and the ratio of true positive to true positive plus false positive. So again, precision cannot be more than 1. We want it to be close to 1. That means we want false positive to be 0, close to 0. And the recall is a separate ratio, which is for true positive to true positive plus false negative. So this is the equal positive that were correctly classified. That's what we are looking for. And that's important parameters. The other parameters used are F1 score, which is the harmonic mean, how much memory you're going to take, how much time you're going to take, what is the training time, and what is the training memory. These are computational oriented parameters. So when you're looking at any algorithm, you all need to look at the algorithm itself and accuracy of that and what the equivalent computing time it will be taking. You need to compare them as well. So when we did this experiment, what we did was to do the following. We took all the data sets which came out of the different machine DS and tried with each machine learning model as well as with our framework. So first we looked only one set of data features that is either dealt by ResNet 50 or VGG 19 or EfficientNet and see how well that performs. And then we said what happens when we do the voting. And the 4 performance parameters are accuracy, precision, recall, and F1, which I already talked about. So if you only take ResNet 50 generated features and try only on one algorithm, KNN, your accuracy is 89% or 0.89. Precision is 0.89, recall is 0.89, F1 is 0.89. The same thing if you take the ResNet 50 data and do on second model, you're getting 0.90. In third case, is getting 0.91, 0.91, 0.91. So this seems to suggest that ResNet 50 data will perform well with the last 3 models here. These 2 don't do very well on this one. But when we do the max voting, you notice that it goes up. So we're only taking ResNet 50 generated features and trying all models individually and a max voting. And we see that each of these parameter value improve. So that's positive. That's what we wanted. And as I said earlier, that when you want to go from 0.91 to 0.92, that is a 1% improvement, which has its own premium. Now, the same thing we did for the VGG19 data. That is, we only took the features generated by VGG19 and tried with each individual model. And the results were between 0.9 to 0.90 to 0.91. But when we did max voting, only on VGG19 data, we did not see much improvement. It's similar. That doesn't give us much hope. So ResNet 50 gives us some hope, VGG19 does not. When we tried only on EfficientNet data, again, it's 0.87 for KNN and goes all the way up to 0.90, 0.89. But max voting does not give you much hope either. So the point I want to make is that the ResNet 50 data gives some hope with the max 50, but otherwise it did not improve much. And that was discouraging. But when we tried all 3 feature sets together, and that's what this last table on the right side is indicating, that we took the data, all the feature sets generated by ResNet 50, EfficientNet, and VGG19, because all the features are in the same format, we could consider that as a single feature vector space, and then tried with individually. So if you try all the combined data with KNN, it goes up to 0.93, which is improving on the KNN itself. And then logistic regression 0.93, random forest 0.92, XGBoost 0.93, SVC 0.93, but the max voting does 0.94. So 2 conclusions can be derived from this. First thing, that using feature set only from one of these algorithms is not sufficient. But if you do fit all three of them, you do improve. I need to improve for individual model, machine learning model either. But the ensemble even gives you additional percent extra, 1% to 2%, depending on which model you're looking at it. So that becomes the overall most effective technique. And you're able to go from 0.91, 0.90, 0.11 to 0.94. This table summarizes that if you only use VGG coding, you do get 94%. So this additional gain is worth the effort. That's one point. And it improves on individual methods. Second point. The other point to note here is I talked about the false negative and false positive and where we should pay attention to. So from our perspective, false negative is more important, that we want to minimize it. We don't want to give a false negative information. I can tolerate false positive. Remember, false positive means that it is not there, but we tell it is there. If we say that, there will be a second level of investigation and the patient will get more options to choose from. But if you give false negative, that's where we make a mistake. So we see there that in each one of them, if we just do VGC 19 with max voting, we are getting 61 cases out of 1,000, which is false negative. Efficient net gives you 60, ResNet gives you 57, but when we use the concatenation of all of them, then we reduce this. So that this is where I want to focus more, because not only we are improving the accuracy, we are also reducing the number of false negative. And that's where the focus should be, because if you reduce false negative, we are misdiagnosing fewer number of times. I mean, desired result here is the 0, but that's not achievable just without automated methods. So this basically gives you a feel for all of this data more graphically, that if you look at only the ResNet data, this bar is only showing that we are looking at the ResNet feature, 50 features there, and what's happening with the true positive, true negative, and so on and so. So blue is the true positive, the green is the true negative. These are all the desired results. So out of 1,000 cases, 923 with the max voting gives you the best result. But more important thing on this side was that how much is the false positive and how much is the false negative. So with ResNet alone, we reduce the false outcomes because we are increasing the false positive side. Sorry, we are increasing the positive with true positive and true negative side. So we're reducing the true positive plus, so false positive plus false negative. And this is the ratio division. And since we are interested in false negative reduction, max voting does reduce. It goes about 57, only with ResNet 50. If we just did the VGG 19, we see the same thing, that it does reduce, but not as much. When we do efficient net, it does reduce false negative, but not as much, it's similar. But when we combine them, our false negative cases reduce quite a bit. So overall, when we look at the results, the false positive and true positive went from 923 to 926. So that was not much improvements in this ensemble before versus ensemble now. But the false positive or false negative numbers shows the reliability. And that's where our result is actually. So then this is what we did, and I just showed to you that overall the false negative reduced down to 40, which is the best result you can get in comparison to anything else. Having done that, the next question then found was that since we're using all the feature extracted data, of course we didn't train the model, we got the features, we use them. It does take computing, it does take memory time. And then when we combine the result, it does save us some time because we know we have to do all the computation, so we can optimize on that and the memory usage. But it still takes a lot more computation and more memory because we are doing more computation. So the question we ask ourselves is, can we do something better? And so I'll come back to this slide in a minute. So our conclusions were that we are, that we are able to do a more reliable framework and reduce the complexity and improve the generalization here. And we said that individually they are not sufficient, together do much better. So that's what the feature space were provided. And we were able to outperform the standard pre-trained models, which was good news. Question is, should we be doing that much computation? So then we said, do I need to do all 5 of the machine learning models? Or do I need to do all 3 of the feature extraction models or not? So when we started looking at that, we did some comprehensive experimentation further and said, can we do 2 out of 3 of the deep learning models? So not try all 3 of them, ResNet 50, EfficientNet V0 and VGG19, but only 2 of them. Question is, which 2? Can we only do 3 or 4 machine learning models instead of 5? So we did pretty exhaustive computation because we have computing machinery available, put it to good use. And we started looking at which will reduce the misclassification, that is a false negative, and do better. It turned out that VGG19 consistently contributed the least to the performance improvement. That is it, after all our exhaustives. What I'm showing you here is all the results only. And so our recommendation then is that not to use VGG19, but only focus on ResNet 50 and EfficientNet V0. It's also, the part of the reason is that it has more feature redundancy with the other models and gives you a lower discriminating power for the melanoma patterns. And so it will increase unnecessary time, so why not ignore that? So we decided not to, our recommendation now is not to do this, and we just say that most effective ensemble focus only on the ResNet 50 and EfficientNet V0. So use the feature set generated by these 2, not all 3, and you probably get similar results. Now, why ResNet 50 works? Because strong at extracting high-level semantic features, and it has the excellent generalization stable gradient. I talked a little bit about them earlier when I described this one-line description. EfficientNet V0 is lightweight and efficient and gives you the fine features. So the fine features with the semantic features together produces better results. That was our conclusion after our experimentation. So when combine these 2 models, and then we try to say probably guess best of both global and local lesion patterns, which will be helpful and help reduce the false negative cases as well. Then we say with these 2 combination, with that combination, what combination of machine learning model will work best? And it turned out that for the DL model, ResNet 50 and EfficientNet V0, machine learning models with KNN, SVM, and XGBoost alone, that is only these 3 instead of 5, are able to give you best accuracy, 94.33%. But still, it increases over the false negative, but it's still lower than other combinations. So the combination, this particular combination is a better combination to make it more efficient and still get similar results as what we are looking for here. So we did many other combinations. I'm not trying to walk through all of them, but try to tell you that if I did ResNet 50 and then KNN, XGBoost, and LR 3 models, this is what we get. The blue is false positive, orange is false negative, and this is the accuracy here. If I take the only ResNet 50 and do these 3 models, this is what I'll get. And I don't expect you to be able to remember the numbers from the next to the slide, but the point I want to show is that if I use these 3 combinations, I'm getting these numbers when I'm using these 3 models, that is SVM, XGBoost, and LR. So XGBoost and LR is common. Here we are using SVM, here we are using KNN. And that gives you similar results, slightly better in some sense. One accuracy is similar, but the false negative goes down, false positive go up. If you use all 4 of them, then we see a very interesting thing here. It actually helps reduce the false positive but it increases false negative. And that's not something we desire. So we use more models, we get more false negative, although accuracy is something similar. So it's very sensitive to what combination you end up using here. Same thing that we tried doing with efficient net B0 data, because those are the other combination we said. And then we show what happens if we use only three of these models, or some other three models and four of them. Accuracy is something similar, but it has impact on the false negative and false positives. So when we use ResNet 50 and efficient net with three of them, that seems to give us the best combination. That was the point of this slide. That individually they are more sensitive, but better, they do better. We still don't get the false negative as we require, but accuracy is high, and therefore, and the computing time is reduced. So now the question is, which one you pay more attention to, computation time or the accuracy? False negative. Accuracy will be similar. You can get that result. So making that comparison was important for us, and this is an ongoing study, so I cannot give you a very conclusive result, but our expectation is that our final conclusion will be that use these two DL models, ResNet 50 and efficient V0, and use these three machine learning models, and that probably is the best result you can get from here. There's one slide I omitted earlier, which I want to talk about a little bit here now. So other thing which is done in artificial intelligence result is that you want to see what impact you observe from combining things. And for that purpose, there are statistical methods available. So these are called scatter plots. What they do is that it reduces your 100 plus dimensions into just a 3D plot where you can visualize certain things. What it's trying to do is to see which combinations are working for you, which combinations are working against you, and what is the overlap region between them. So simplistically, that's what this slide is showing here. And this is called the T-distributed stochastic neighbor embeddings. And what it shows is that when we combine these models, we are able to get a better distinguishing power. That is when I look at this plot, more yellow are confined in one side, the orange, which is the bad cases, are plotted on the other side, and there's a little bit overlap. Eventually, your goal is if the overlap is 0, then you will get 100% accuracy, but that's not there. Therefore, you get this result from here. So that's the scatter plot in case you are interested in this result. If not, what you're really interested in is knowing this result, that use these two DL model and remember, use these three machine learning models, and you are able to get the best possible results. So that's the outcome of our experimentation here, and that's Himani's ongoing work. So hopefully next year she will have some additional things to say about this work. Thank you for your attention. If you have any quick question, I can answer that. Otherwise, we are pretty much on time.
Thank you, sir, for your support. Thank you very much, sir, for such an enlightening address. Your insights into fault tolerance in artificial intelligence and its impactful application in early skin cancer detection have truly broadened our perspective. Ladies and gentlemen, we shall now proceed with the next segment of the conference. It is our great privilege and honor to introduce Professor Dr. Anita Saravana Kumar, Assistant Professor at the Gildart Haase School of Engineering, Fairleigh Dickinson University, Vancouver. Professor Dr. Anita Saravana Kumar is an accomplished academician and researcher with over 20 years of experience in academia and research. She holds her PhD in electrical and computer engineering from Toronto Metropolitan University, Canada, and another doctoral degree in information and communication engineering from Anna University, India. Her research interests include autonomous vehicular networks, edge network resource management, blockchain technologies, and machine learning based security. She has published over 30 peer reviewed journal and conference papers, including articles in leading IEEE transactions. Professor Kumar also actively contributes to the research community as a reviewer for prestigious IEEE journals and has served as a technical program committee member for major international IEEE conferences such as GlobeCom, ICC, and VTC. Her contributions and leaderships have been recognized through several honors, including IEEE WIE Student Grant and the Outstanding Woman in Engineering Award from the Venus International Foundation. Now, I request Professor Dr. Anita Sarvara Kumar to kindly address the gathering in the topic The Magic of Artificial Intelligence in Vehicular Networks. Ma'am, please.
Thank you very much for the warm welcome. I would like to present my presentation. Presentation. Good morning, everyone. Today, I'll be presenting about the magic of artificial intelligence in vehicle networks. I am Anita Saranakumar, and I'm here to present you about the artificial intelligence in transforming vehicle networks, particularly through edge computing and federated learning. This talk will be focusing on. And this talk highlights my recent research contributions and the publications in transactions on vehicle technology, just focusing on intelligent transport allocation and computation offloading in Internet of Vehicles and environments. I will begin with the brief introduction to artificial intelligence, and followed by the motivation and the challenges in vehicle networks. I will then explain the system architecture of vehicle edge computing as to networks. Also, I'll be presenting about the very important work which is focusing towards asynchronous federated learning based computation offloading. And finally, I will conclude with the key findings and the future research directions, as well as the industry opportunities, which will be there present for this type of work. Basically, when we think about artificial intelligence, it refers to algorithms and systems designed to imitate human intelligence, including learning, reasoning, and decision making. In networking and transportation systems, AI plays a vital role, and it enables adaptive, data-driven, and autonomous optimization decisions that are not feasible with static rule-based methods. So here we should know about what are the AI functionalities we have, and then how we are going to use it. Basically, artificial intelligence functionalities describe how AI systems operate and respond to the environment. Here we have many functionalities, starting from the reactive machines, which act only on current inputs without memory, such as chess engine. We can give a best example, which is chess engine evaluating the present board state. And then we can also say about the other functionality, which is limited memory AI, the most common today use, and it learns from the historical data to make decisions. We can say, for example, the autonomous vehicles use past sensor readings to make decisions, like to predict the pedestrian movement. And then also now we can say another functionality, which is theory of mind, which is the theory of mind AI, which is aiming to understand human intentions and emotions, while the self AI also would possess the consciousness, both remain very theoretical, largely theoretical. In practice, modern applications in transportation, healthcare, and finance rely primarily on limited memory AI for adaptive data-driven decision making. AI capabilities are majorly classified into three categories, like weak AI, we can otherwise also called as artificial narrow intelligence. It is designed to perform a specific task efficiently, example like voice assistance, recommendation systems, AI-based traffic signal optimization, and then the next other one we can say it's artificial general intelligence, which is a strong AI, which is refers to hypothetical AI that can understand, learn, and apply knowledge across multiple domains, like human, such as reasoning across unrelated problems. This level have not yet been achieved, but still is and a potential way of research is there, focus is there. And then the AI, artificial super intelligence, which is that even surpasses the human intelligence in all aspects, including the creativity, decision making, and it's purely and theoretical at this present moment. So, what are the AI technologies helping to attain the dreams into like real time? They can see many AI technologies are there, and AI technologies imposes of a set of tools and methods that enable intelligent behavior in machines. Machine learning allows us to learn the system pattern, allows the systems to learn patterns from data, such as predicting the traffic congestion from historical vehicle data. And the automation enables repetitive tasks to be executed without human intervention. For example, automated toll collection systems. Computer vision is used in autonomous vehicles to detect lanes, pedestrians, and traffic signs. Of course, the natural language processing powers voice assistance in vehicle commands. Robotics and autonomous vehicles integrate these technologies to enable self-driving cars and intelligent delivery vehicles operating safely in dynamic environments. All this technology definitely motivates some research, right? So here is the motivation. Vehicle networks are becoming the ubiquitous with the rise of Internet of Vehicles and intelligent transport systems. Applications such as autonomous navigation becomes ultra low latency. Vehicles have very limited computation and energy resources. Of course, we can also say the emerging vehicular communications are expected to enable entirely a new array of services, making our daily experience on vehicles more safer and more convenient. Applications, you can say autonomous navigation require low latency and limited computation and energy resources. These conventional optimization techniques are insufficient in motivating the use of insufficient to address these issues. So that motivates the use of the reinforcement learning techniques approaches for adaptive scalable solutions. Which is challenging to the advanced vehicle networking technologies to accommodate new services and applications, practically that demand quality of service requirements and the strong underlying dynamics of the vehicle environment. We use multi-agent reinforcement learning techniques to solve these issues. So generally for this, we need a vehicle assisted network, which is VEC, as autonomous vehicle technology advances efficient information sharing with a large network of connected and autonomous vehicles, which becomes very essential. As a result, many researchers are focused on VEC-based computation resource allocation and optimization schemes, which is mainly focusing on low latency communications, low energy consumptions, high computation rate, scalability and flexibility, network efficiency, and so on. So this is major platform where the highest research is going on vehicle networks. So here we are here to present an published paper in TVT. I'm here to present a published paper in TVT, which is published in December 2024. It's basically to provide an privacy concern, like considering the privacy concerns when outsourcing data is being given to the edge networks. When the vehicle is uploading data to the edge networks, how far our data is more secure. So that's a concern, right? This work introduces an asynchronous deep federated learning approach for task computation offloading techniques to maximize computation rate while ensuring the queue stability and the data privacy. And here you can see in the figure, this is the system model, and assume like here the macro base station is associated with V road units, RSUs, and K vehicles, and its MBS is the macro base station, and it is associated with the cloud server. And each RSU is associated with a VEC server. Each VEC server is associated with the group of vehicles. So we formulated a problem here, like considering when the data is being offloaded to the edge server, how secure the data is being offloaded. To tackle that, we are employing Lyapunov optimization-based technique, which maximizes the computation rate and definitely does the trade-off between the queue stability and the packet drops. Because we know, as we all know, once you are going to have a trade-off to reduce the packet drop, then definitely the delay is increased, right? So in order to have a better trade-off, we have introduced a Lyapunov optimization technique. The parameter is the Lyapunov control parameter epsilon, and it's a tuning parameter between the stability and the packet drops. So we convert and solve this optimization problem as a non-convex problem, and we propose an Lyapunov guided asynchronous federated deep reinforcement learning method, which is AFDRL, and it's a long-term limit, like to separate the long-term limitations from the short-term optimization, we employ Lyapunov optimization. And we can see here, we have constraints C1 to C9, and all these constraints like C1 to C9, like decision making, task operand decision making is from constrained C1 to C2, and C3 to C5 they contribute to the resource constraints, as well as our C6 to C7 for queue constraints, and C8 and C9 with delay constraints. So basically, we are trying to introduce a Lyapunov optimization and produce a trade-off between the queue stability as well as the packet drop. And for this, we are the state space considers the from S1 to SK of t, and the E state space, we have considered the position of the vehicle and the speed of the vehicle, as well as what is the data is being to be for computation. Keeping that in mind, each action is being contribution to the constraints whichever is available here. So those constraints are the decision making, as well as the position of the vehicle, as the frequency, as well as amount of data being uploaded. So our aim is to maximize the computation rate of each vehicle subject to the system, resource, and delay constraint. And so we are focusing towards like how to design the reward model, and provided we are taking the logarithmic of the computation rate, and of course we have a penalty. So if any one of the constraint is not being addressed due to this action A of t, definitely we'll have a penalty. The total reward is then given as the summation from K1 to K or K of t. Having said that, we are considering and leveraging the federated learning to fulfill the computing task towards a data sharing request. The vehicles are the training nodes here, which are the clients, and the MBS is the aggregator, which is the cloud server. So hence the AFDRL, which is the proposed asynchronous federated deep learning DQN network, includes a global DQN and local DQN. And the MBS server will be acting as a charge of updating the global model. And the proposed AFDRL allows the vehicle to upload the local model asynchronously to ensure that the local models are fully trained to guarantee the convergence and the efficiency of the global model. The federated DQN allows the newly arriving vehicle to download the well-trained global model from the MBS server, which is which is trained by the distributed vehicles under the coordination of the MBS cloud server. Thus, the proposed asynchronous federated architecture consists of the global model downloading, which is on the nth time slot, the newly arriving vehicles download the evaluation parameter as well as the target parameter from the MBS server, and then set the local model parameters, which is with respect to the evaluation K as well as the target parameters. And then the local model training is being set. During the training, the evaluated trained is parameterized by the drift plus penalty formulation, which is the epsilon, and then utilized to compute the expected value of the subsequent state. And for the local model update, generally the agent then compute a gradient based on the previous experience and updates the local model by changing the evaluation parameter. So the final the step involved here is the federated averaging, which is the global model is obtained at the end of every round by taking the weighted average of the parameter of all the local nodes involved in the learning. So that's this is everything when all the uploaded local models are received at the end of the time slot, then the MBS server executes the federated averaging based on the updated local model as given in this algorithm. So it updates the global evaluation network and the global network according to their values updated. We can see our results are promising with respect to the impact of the epsilon, because as when the packet drop and when the computation rate as we tune the epsilon, and there is a trade-off between the packet drop and the computation rate, we can see the packet drop decreases with the proposed AFDRL method with fine-tuning of the epsilon. And we can see from this figure, like the queue backlog is also being reduced with the fine tuning of the epsilon, and it's being maintained to the constant level as in the epsilon value keeps gradually changing. At one point, it becomes a constant for the given value of 6 and so on. Basically, we can see the learning of all the 4 algorithms as shown in the figure here with respect to average reward at the episode, and the average reward gradually increases, maintaining a stable positive reward for both the approach as well as the proposed algorithms. Our proposed algorithm exhibits a minimal variation here due to the highly stable training process. And also we can see in the figure which is with respect to our focus is on the computation rate, to increase the computation rate, right? With the number of vehicles, we have checked with how the computation rate is exhibiting with respect to megabits per second, and we can see this figure illustrates very clearly the average computation rate of the vehicle for the 4 distinct algorithms. As the number of vehicle increases, our proposed algorithm promises because our algorithm dynamically adjusts the offloading decision based on the fluctuation of the channel state to optimize the execution of the computation task. So thus, our results show the improved computation rate, reduced packet drop rate, better queue stability, and enhanced energy efficiency compared to the benchmarks. Because of time limit, I've just shown you only the results corresponding to the computation as well as the tuning parameter. So this our work, this is one of my work which is focusing on non-convex optimization using the multi-agent deep reinforcement learning technique to support the performance of privacy preservation and the computation rate. And it has addressed the privacy concerns through asynchronous federated learning. And we have done for the real-time data set for California data set, which is through the network simulation with using PTVSIM, and federated learning technique and asynchronous federated learning techniques being considered here. So basically, you can see the future research of this work. It can be expanded to the UAV assisted networks, SDN integrated VKC network. Actually, I worked on these 2, and now we have a solid result, and it's under the process of publication. for SDN network as well as the SDN VC environment. So again, like the data privacy can also be improved with a blockchain concept integrated with federated learning concept, and the large language models can also be included with 6G. We are in the huge research is going on. So this is how it is, and definitely this kind of research will provide an industry impact, like for the emerging technologies. But there is a future job opportunities way high for this kind of research and job, like who the people are working with. So, and the job descriptions are basically the AI engineers and robotic engineers, data scientists, test engineers. Of course, there is even the emerging technologies also enabling the careers towards autonomous driving, edge AI robotics, and AI safety, multimodal AI models, and edge AI. If you have any questions, you can ask me. Thank you. Thank you for the patience.
Thank you very much, ma'am, for such an insightful and informative address. Your session offered a valuable perspective on the transformative role of artificial intelligence in vehicular and intelligent transportation systems. Thank you so much. The next session will commence at 12:30 p.m. And research. He has held several key national leadership roles, including Executive Director of the National Information Technology Center and Project Director for major ICT initiatives supported by ADB and COICA under the Government of Nepal. Professor Shakya's areas of expertise span information systems, software engineering, databases, e-governance, cloud computing, and big data. He has played a pivotal role in curriculum development and higher education governance, serving on national academic councils and advisory committees. He has also coordinated international academic programs under Erasmus Mundus, fostering global collaboration in engineering, education, and research. Now, I request Professor Dr. Subarna Shakya to kindly address the gathering on the topic Artificial Intelligence in E-Governance, Impact, Challenges, and Opportunities. Sir, please.
Okay, thank you very much for this opportunity, and I special thanks to MET School of Engineering and Technology for invite me as a keynote speaker in this 16th International Conference, Confluence 2026, organized by MET University, Noida, New Delhi. My keynote topics is Artificial Intelligence in E-Governance, Impact, Challenges, and Opportunity. So my talk is as follows. So introduction to e-governance and AI, then after that, historical milestone and government initiative in and policies, current and emerging uses of AI in e-governance, then after that, positive impact of AI on e-governance. Yes, then after that, core AI application in administrative function, and I can talk about case studies from other countries like UK and USA. Impact of AI in e-governance, challenges in implementing AI in e-governance, then after that, opportunity and future potential. Then after that, developing the roadmap for success, the future of AI in the e-governance, then conclusion, strategic recommendation. So introduction to e-governance and AI is, the e-governance is referred to the application of ICT to provide government services, enhance transparency, and engage the citizen effectively. It signifies the shift from traditional governance model to more participatory framework that facilitate efficient service delivery and empower citizens through the digital platform. And then AI enhance e-governance by automating processes, decision-making improvements through predictive analytics and personalizing the public services. By analyzing vast data sets, AI can identify patterns that lead to more informed policy, medicine, and enhance the service efficiency. So I can talk about some historical milestone and government initiative in Nepal. Nepal begins explore ICT in governance during the late 1990s. Then after that, post-IT policy were introduced in 2000. High-level commission for ICT was established in 2002. E-government master plan 2007 supported by Korean IT industry promotion agency, we can say as a KOICA, not KOICA, this KIPA, Korean IT industry promotion agency. Then after that, establishment of National Information Technology Center. Then government integrated data center was established in 2008. Then after that, disaster recovery center in 2019. Then digital Nepal framework in 2019. And this is the data center established in Nepal. This is the recovery center established in Nepal in Hetauda site. So government initiatives and policies are online service. That means birth, marriage, registration, passport applications, PAN registration, and e-payment of utilities, and e-government portals, official portal like nepal.gov.np offer ICT information public services. Then NID, biometrics national ID card implementation is the crucial steps towards the digital identity. Then after that, online tax system, inline revenue department, e-filing and e-payment system. Then after that, another is the e-procurement, the public procurement monitoring office, PPMO runs, and e-bidding platforms. So next is e-governance blueprint draft in 2081 on Wales by e-governance board under the office of the Prime Minister. This is the blueprint aims to create the fully digital paperless public service system. The main objective is that building digital infrastructure, formulating legal framework, and encouraging the innovation in the digital governance. Then after that, another is the National AI Policy, just 2025. This is a new AI policy in Nepal. This policy prioritizes leveraging AI to enhance transparency, corruption reduction, then improve the government efficiency. It emphasizes the creation of the AI research hubs and support for the AI startup through the financial initiative and public-private PPP model. So digital service automation is another part is there. Then after that, data analytics for the policy making, and then smart cities and infrastructure, agricultural support system, digital identity and verification, national ID and biometrics in voter registration or citizen databases. Then after that, would eventually integrate AI for biometrics authentication, fraud detection, duplicate identity elimination, judicial automation. These are the few current and emerging uses of AI in the e-governance. Positive impact of AI in the governance is efficiency of the service delivery. And then after that, we can improve the decision making also. And then after that, we have to enhance the transparency and accountability. And there is the cost reduction. faster credentials and personalized public services, smart governance and urban management. Another is the prediction and preventive governance. The inclusive governance, strengthen the citizen engagement is another positive impact. Then after that, core AI application in the administrative functions are automation of the administrative tasks. AI streamlines bureaucratic process by automating repetitive tasks such as document processing, data entry, and record management. Next is we have this automation reduce administrative burden and allow the government employee to focus on more strategic activities. Another is the enhanced decision making. AI system analyze vast data set to provide insight that support informed policy making. It is very easy for the policymaker to get some data, and then after that, easy to policy making also. By identifying patterns and traits, AI aids in crafting policies that are data-driven and responsive to the citizen needs. Another is the core area of AI application in administration functions are improve the public safety and security. That means AI technologies, including facial recognition and as well as the predictive analytics, assist law enforcement agency in the crime prevention and investigation. The next is these tools enable quicker identification of threats and more efficient allocation of the resources. The impact of AI in the e-governance is better decision. I just mentioned it, and then after that, I just want to elaborate. Reimagine the service delivery also, and also robotics process automation, enhance the accountability and transparency, inclusivity and accessibility. Better service delivery is the another part. We can increase the accessibility, predictive governance, then cost saving and efficiency. The case study from other countries like UK and USA. In United Kingdom, UK, government has explored AI to enhance public sector productivity. That means we estimate suggesting potential saving of up to 25 billion pounds annually through the automation and improve the efficiency. In the case of California and USA, California has initiated the use of generative AI tools to improve the public services, including traffic management as well as tax guidance, aiming to increase the accessibility and the efficiency. So there are so many challenges in AI in e-governance. We need to do some research in this area. So the researcher students, they can focus in this area to do their research. Data security and privacy is the very challenges in the e-governance if we are using the AI. And ethical concern is another part. Trust is the another part. Internet access and the digital divide. Building professional skill and capacity is the crucial. Environment impact, then integration with current platform. Then after that, legal and regulatory framework is the most important to effective implementation of the e-governance in the AI. When you are using the AI in the governance, these are the few challenges. Cost and scalability, then evolution of the AI, bridging the skill gap and developing capacity, accountability and transparency. These are the few challenges in AI in the e-governance. The opportunity also there are so many opportunity and future potential is citizen-centric services. Then after that, we have some predictive governance. Then after that, AI has the potential to complete the platform, healthcare and education industries also. AI-driven solutions help farmers and rural community in agriculture and rural development. So AI has potential to revolutionize both infrastructure management, the smart city design, and multilingual service and language translation, with mitigation of climate change and preservation of the environment. So developing the roadmap, we need to develop some roadmap for this particular case. The capacity building is the most important in AI in the e-governance. That means we have to invest in the capacity building through training program or civil servant can enhance skill related to AI technologies. So empower personnel will facilitate a smoother translation into AI, assist governance and foster organization efficiency. Then policy framework is another part. establishing robust policy framework governing ethical use of AI in the essential. Clear guidelines can be addressed data usage and privacy concern while ensuring accountability and transparency in the AI implementation. So next is we have PP model is the most important when you are going to implement AI in the governance. PP model is the important. That means collaboration between the public private sector can foster innovation, share resources, and integrate diverse expertise in the development of the AI solution. This partnership can provide the necessary support to overcome implementation barrier effectively. So another future AI in the governance is key insight is we have to identify key insight gained from previous discussion highlight the critical role of AI in the reshaping the governance structure. We have to do some reshaping the government and improving the citizen engagement is the most important. And we have to enhancing the operational efficiency. The main another is the recommendation based on the challenges. There are so many challenges I already mentioned in that. And there are challenges and opportunity explored throughout this presentation. Tailor recommendation for the government initiative can guide effective AI integration in our e-government implementation in this sector, ensuring that technology serve the public goods. Then after that, the vision for the future. That means envisioning the future where AI is the seamlessly integrated into governance, foster hope for improved public administration processes and elevates citizen interaction with their government. So, and my conclusion and strategic recommendation is AI into governance presents significant opportunity. There are so many opportunities there. Nowadays, every system is going to be automation in decision-making sector. So, for revolutionization the administrative procedures, improving the citizen service and promoting the transparency. Then we need to do machine learning and deep learning also most important for effective implementation of e-government. Natural language processing and data analytics are the example of the AI technologies that present chances to automate repetitive operations, enhance decision-making, and provide the citizen with individualized services. The effective application of AI in e-governance is necessary, giving the considerable through the ethical, legal, and social ramifications of the decision as well as to the cyber security, digital divide, and data privacy concern. So AI might enhance service delivery and expedite government processes. It also presents issues including algorithmic bias, lack of accountability, and the possibility of the job displacement. In order to effectively control AI, authorities must take the comprehensive approach. That means include strong legislative framework and multi-stakeholder collaboration and capacity buildings. AI has the potential to revolutionize the e-governance by making public administration more effective, transparent, and as well as the citizen-centric. The successful implementation can addressing challenges related to ethics, privacy, and inclusiveness and regulations. With appropriate policy, robust legal framework, and capacity buildings, AI can serve as a powerful tools for sustainable and inclusive governance. So main thing is that just simple e-governance is not sufficient nowadays. So when you are using the artificial intelligence in the government system, developed country and developed country that can, so we can make it smooth service. That means government to government service also, and government to citizen service also, government to business, and as well as the government to employee. Every system must be transparent and efficient way, so that we have to make the policies very important policy, and the framework is the most important when are implementing such type of tools and techniques, because the policy is the most important. Policy plan and vision is the most important. Then technology will come. Then technology we can implement it. So university can do such type of research, how to effective and efficient government system in the developing country and as well as the developed country. These are the few things we have to consider in my presentation. So these are the some conclusion and my recommendation. We have to develop very effective and efficient framework policy for effective implementation of the AI in the e-government or e-governance system of the country. So these are my few references. Yeah. And thank you very much for nice listening, participation, and all the ladies and gentlemen. Thank you very much. Thank you very much. I finish my presentation. If you have any questions. Hello.
Thank you very much, sir, for such an insightful and thought provoking address. Your
Mhm.
perspectives on the integration of artificial intelligence in e governance and its broader societal impact have provided valuable insights for all of us. Ladies and gentlemen, we shall now proceed with the next scheduled segment of the conference. It is our great privilege and honor to introduce Professor Dr. Kire Yakimosuke, Associate Professor at the Faculty of Informatics, Von University, Skopje, Republic of North Macedonia, and Dean of the Faculty of Informatics. He also serves as the Vice Rector of Von University, Skopje. Professor Dr. Kireyaki Moske received his BSc degree in telecommunications from the Military Academy Mihailo Apostolos in Skopje in 2002. He completed his MSc in electrical engineering telecommunications from SS Cyril and Methodius University, Skopje in 2007 and earned his PhD in technical sciences from the same university in 2013. From 2002 to 2006, he worked as an officer for telecommunications in the Ministry of Defense of the Republic of Macedonia. From January 2006 to February 2012, he served as an advisor for information security in the InfoSec division within the Directorate for Security of Classified Information in Skopje. Since March 2012, Professor Yakimosuke has been associated with Foreign University, Skopje, contributing extensively to academics, administration, and research. His research interests include wireless and mobile networks, heterogeneous wireless networks, computer networks, and information security. Now, I request Professor Dr. Kireyaki Moske to kindly address the gathering on the topic Intelligent Compliance using Automated Risk Assessment via Firewall Telemetry. Sir, please. It is our great privilege and honor to introduce Professor Dr. Kireyaki Moske, Associate Professor at the Faculty of Informatics, Fon University, Skopje, Republic of North Macedonia, and Dean of the Faculty of Informatics. He also serves as the Vice Rector at Fon University, Skopje. Professor Dr. Kairi Yamovsky received his BSc degree in telecommunications from the Military Academy Mihailo Apostols in Skopje in 2002. He completed his MSc in Electrical Engineering Telecommunications from SS Cyril and Methodius University, Skopje in 2007 and earned his PhD in Technical Sciences from the same university in 2013. From 2002 to 2006, he worked as an officer for telecommunications in the Ministry of Defense of the Republic of Macedonia. From January 2006 to February 2012, he served as an advisor for information security in the InfoSec division within the Directorate for Security of Classified Information in Skopje. Since March 2012, Professor Yakimoski has been associated with Fon University, Skopje, contributing extensively to academics, administration, and research. His research interests include wireless and mobile networks, heterogeneous wireless networks, computer networks, and information security. Now, I request Professor Dr. Kairi Yakimoski to kindly address the gathering on the topic Intelligent Compliance using Automated Risk Assessment via Firewall Telemetry. Sir, please.
Okay, I hope that you can hear me well. Can you hear me well?
Yes, sir.
Okay, thank you for your warm welcoming. Ladies and gentlemen, just to add at the end of my biography, I'm currently full professor at the Institute for Cybersecurity and Digital Forensics under Military Academy General Mihailo Apostolsky in Skopje, Macedonia. And in this half an hour, I will present my today's chosen topic. As you have mentioned in my introduction, the topic is the next generation of cyber risk management, when we are using both human and machine learning, artificial intelligence efforts in order to make modern and fully automated, of course, with human help, cyber risk management. I will now open first the presentation that I've prepared for this keynote speaking, and then I will make some live demo with firewall in order to see the practical part of my today's presentation. Let me just share my screen here on Zoom. Share screen. Share. Okay. This is the topic that I have chosen. Once again, the title is Intelligent Compliance using Automated Risk Assessment via Firewall Telemetry. And let me make some slideshow first. Okay. So key issues in this topic is that compliance is currently a static snapshot, and efforts are doing all over the world to be automated using the newest technologies. Why this is very important? Because manual audits on the systems, on computer networks and systems, when we are doing cyber risk management, that when we are assessing the risks that could exist in our organizations, institutions that use computer systems and networks, they are becoming obsolete within 24 hours. Why? Because the landscape of cyber attacks is very dynamic. It changes from minute to minute, and that's why we must have automated and very, very proactive cyber risk assessment of assets that we possess in our organizations and institutions. Very good point of taking the data are firewalls, because they are protecting the whole perimeter of the networks, and they have a lot of telemetry. But if we don't have the whole picture covering the risks that could exist, we have little insight. Another skill gap in the organizations is shortage of CISO, Chief Information Security Officers, and risk officers that are dealing with this broader picture of taking control of the risks that could exist in the companies. So that's why the vision here is to move from point in time to continuous risk assessment that could have the whole picture of the risks in any time in a day. First, what is firewall telemetry? It's actually the main source of truth when we are protecting networks and computer systems, because here we have a lot of logs, we have a lot of alerts of events that are happening in each second in the computer networks that are connected to internet. We have here IDPS alerts. For example, suricata events are one of these IDPS alerts. IDPS is abbreviation, for those who are not familiar with this, intrusion detection and protection systems. So we detect and protect systems with this kind of, for example, suricata events that are detected. Then we have application control logs, another type of firewall telemetry. We have metadata, we have traffic flows, and these are just some of the parameters that are used in the firewall telemetry. Telemetry is actually the pulse of the network, because it gathers all important things that are happening in our networks and systems regarding processing data, sending data, dealing with applications, etc. So the framework that is done here on this particular firewall that have my input in it from Australian company Red Piranha, the firewall is Crystalline, to put together the telemetry and the configuration audit, and at the top of this to map this to well-known standards like CIS version 8.1, where we have safeguards and controls, and ISO 27001 controls. Here, in this particular effort, we have dynamic risk score from 0 to 10 in order to measure the risks from insignificant to very high risks. So we are, first of all, at the top of all our assets. So we are linking assets to the firewall data in this framework in order to have the whole control of what happens in the network and system that is protected by the firewall. So we are doing first firewall mapping, where applications automatically pulls a list of active devices that are detected by the firewall. And then when we have detection of the active devices, we can make successful audit in order to gather all risks that could exist in the computer system and network. In order to have good control of this, we are using CIS version 8.1 standard for division of the assets, and we have good division according to this standard in 6 categories. For example, software, data, users, documentation, devices. And when we are assessing risks, we are doing in asset-based type of assessing. For example, generate the type of risks from very low to very high. It depends from the answers. And this is why this is good initial risk assessment where we have good control, because after that we are using the risk strategies for these risks. And we have 4 risk strategies according to all methodologies nowadays: mitigate, transfer, avoid, and accept. And we have in this order good treatment of risks. And when we have the risks, we should make prioritization. For example, first we are treating very high risks. They are flagged first, and they require immediate remediation steps. And for that, we have advice column. We can view on this platform that is, I will show you in a few minutes how it looks like, the risk trend. We can see the gap between open and closed risk. And in that order, we have good managing of the situation with the risks that we are treating, which are open, which are closed. We have timeline, and we are seeing the gap between them. And because the risk is not static, we have option to edit and update the risks when we are implementing fixes. We can return to the assessment and change the answers of the questions. For example, some of the answers that were no after treating the risks are yes, we are changing them, and we are making another assessment and update the record and update the state of the risks. And we have, in this way, we have a review cycle. Firewall can track the next review date for every asset. And in this way, we are ensuring that risk audit stays current and doesn't expire. Why this is good methodology? Because in the same time, we have compliance with standards like ISO 27001. And if we want to have external audit from, for example, some of these officers that are doing external audits in order to get this kind of certificate to be compliant and to have good reputation of your company, because now, for example, third-party risk assessment risks are very, very hot topic, and every organization, when wants to communicate, to make business with other organization, they are also, for example, checking if this organization is compliant with cybersecurity standards, because there are a lot of attacks lately that are using this shortage, this weakness in the organizations, and attack from their collaborators if they are not having implemented cybersecurity standards as they should. So the future is human-machine teaming, because now we have security professionals that work in automated world. So we must use artificial intelligence and machine learning in order to predict risk trends based on historical telemetry. And this is very important, for example, for small and medium enterprises, because they cannot afford to fully employ a whole team of cybersecurity experts and chief information security officer, risk officer, etc., compliance team, SOC team, etc. So having these kind of platforms that are integrated in the firewall, they have good replacement for employing several cybersecurity experts that should do this job. So I will get back to this conclusion after the live presentation. Let me go now with my presentation of the firewall. So now I'm approaching the firewall. I'm logging on the firewall. This is the first dashboard. In this dashboard, you can see the network LAN interface report, On this graph, you can see on the horizontal axis, you can see the dates, and on the vertical axis, you can see the traffic flow in megabits per second. Then we have next network external interface reporting received and transmitted megabits per second. Then we have here process CPU usage, process memory usage. These are some of the measurements that are here. Application status. We have system drive, recent software activities in the firewall, for example, CM, IP settings, system software updates, etc. This is system dashboard. Then we have security dashboard. I will just explain now first the dashboards, then I will go to the main thing. This is security dashboard where we can see the incidents that are detected here. For example, we have here timestamp, source, destination, country, region, description, rule type. For example, this is potential bad traffic. And on the right side, we have action. For example, this is allowed, severities to port MAC, HTTP port information. And if we click here, we can see more information about this event, this alarm, and we can change the rule actions. For example, we can make here from alert to, if we decide that this is for rejection, we can put reject. So this is the world map, and if some of events are for alerts, they are shown here. For example, let me go on the last 30 days. And you can see here also, as you can see in the map from where it came. Then this is the third dashboard, threat hunt dashboard. I'm showing this with dashboards in order to see the telemetry first. So we have here total threat detection, devices with detection, detected external IPs, top seeds in numbers. Then we have here more tabs, threat dashboard. These were summary, threat dashboard, where we can see the statistics of events. Then we have threat report. Then we have M365 threat hunting. This is for Microsoft 365 application. Network threat hunting. Then we have AI and escalation reports. For example, here AnyDesk was used and it's detected here, and active sessions. These are active sessions. So now I'm going to the main thing. This was different kinds of telemetries that could be detected with the firewall. In the compliance controls, we have risk auditing option. And this is the part that I was talking about, where we can use firewall telemetry in order to make fast risk assessment. This is actually my invention here. We can start with create assessment button, then we are selecting framework. This is EG1 framework from CIS version 8.1 standard. And this is very important part. We are selecting asset type. So now we have 6, as I said, asset types: network, data, software, users, devices, and documentation. For example, we want to assess the users that are using the computer systems in our organization. As you can see, when we are choosing users, automatically here, all devices that are connected with the users in our organization are shown here automatically. This is the part that I have said automation is very important when we are making risk assessment, and automation with the assets that we possess is the beginning of the whole process. Now we have the assets that are related to the users, and for example, we want this laptop to be excluded for this assessment, because we don't want to assess the users that are using this laptop. It's not relevant for our organization. We are clicking exclude here. So we want to make risk assessment of the users that are using these two machines. As you can see, they are desktop machines. The best approach here is to do this with the at least sysadmin of the company that is managing the assets in the company devices. With his help, we are checking these questions here. For example, do you require multi-factor authentication for all administrative access accounts were supported on all enterprise assets, whether management on-site or through a service provider? If some of them is implemented, we put here partially. If all, yes. If nothing from these controls is, for example, do you train workforce members or on authentication best practices? Example topics include multi-factor authentication, password composition, credential management. If the answer is no, we put here no. This is part of the topic security awareness and skills training. Here we can see the categories, topics of different implementation controls. And we are doing this with all these several questions here. Yes, no, partially, etc. Depends on the implementation. I will do this now randomly in order to finish with this part. And after answering all questions with your yes, no, partially, for example, this is partially, we are clicking here submit. When we are clicking here submit, this first assessment is done, and we can see the time step here. The time step says the asset type is user, submission date is now, and here we have edit assessment. I've said previously that we can, after making some improvements in the controls, we can edit the assessment. We are doing that part here, clicking here, edit, and changing some of the questions. For example, after implementation of this control, MFA for remote network access, we put if it was no, we are putting now yes. Or here, this was no. Now we are training workforce. We put yes. And hit update. The risks will change now. But where we can see this? We can see the risks here in the reports part. We have different kinds of reports here. The report for the risks is risk report. And here we have main dashboard. We have risk trend, where we can see the timeline of opened and closed risks. This is good for having the whole picture, what we are doing in, per example, last month or last year with risks, how many were open, how many were closed. Then this is actually the most important part, the risk advice. Here, the risks are generated. This is the risk, for example, after answering those questions that I've previously shown. Here, the risks are generated automatically. For example, the risk here that is very high is attacker can exploit vulnerable services and settings to compromise operating systems and applications. What we can do with this? The answer is here. Our advice is to establish and maintain secure configuration process for network devices. We should review and update documentation annually, or when significant enterprise changes occur that could business impact this safeguard. So we are approaching first very high risks, and after very high we are the next are with the lower levels. Here we can see some risk with medium. And next important thing is when we should review the risk. This risk is opened at the end of this December. last year. And next review date says it's in 1 month. So we are checking in this month if we have done something or no. If we have done something, we will, of course, change in the edit assessment the answers of the safeguards that I have previously presented you. And here the risk maybe should from very high change to medium. It depends from the safeguards that we are implementing for that particular risk of the asset. And the asset type is also very important. So now, as you can see, our last assessment is not shown because it needs some time. It needs some, for example, 15 minutes, half an hour. When it will be done, it will be shown here, like this for users. We can see now here last month, the end of last month in December 28th, the assessment was done of another users here, and the risk for them is very high. We should make some immediate remediation here in order to mitigate this risk. And this is very good control because here we have the asset type, we have the level of risk, we have when we have opened it, when is the next review date, we are governing the risks in this way. And this here we can see the submitted risks, who submitted the risk. For example, I've logged in on this firewall with admin user. I was submitting the risk, and when I submitted the risk, we can see here. Here the strategy should be shown for 4 types and the level and asset type. So here on the dashboard we can see risk status, how many are open, closed, pending, closed, in progress. Risk strategies, we have 4 strategies: to accept the risk, to mitigate, to transfer, and to avoid the risk. What is to avoid the risk? To avoid the risk is, for example, the risk is connected with some application. We are removing that application and we don't have the risk. What is transferring the risk? We cannot solve this risk as company. We are, for example, assuring this risk, pay money to some assuring agency, insurance agency, and they are responsible for that risk. If that risk happens, they should mitigate this risk, put money on mitigation. Mitigation is when we have power to solve the risk by ourselves as company, and accepting the risk is when we are, for example, assessing that if we treat the risk, the money that we will put to treat the risk is not afforded because the risk itself costs less than the money that should be put to mitigate the risk. So we are accepting the risk. Here we have risk levels. This is good pie to have control how many levels, how many risks are with very high, medium, low, insignificant, etc. And here we have risk owners. Very important part about the risks is who owns the risk, because who owns the risk, he is responsible for that risk. And usually, when we are deciding who owns the risk, the owner of the asset should own the risk. So in this way, we are putting obligation and responsibility of the risks. So let me go back now on the presentation, conclusion, current slide. What can we conclude from this topic? That cyber risk management is more than needed in organizations and institutions nowadays, because we are living in digital world. Digitalization is happening with very fast pace in all organizations, and the exposure to cyber attacks is very large, because we are all connected as organizations that are digitalized on the internet. We should put a lot of effort in order to govern the risks that could happen in our organization. So cyber risk management in this particular topic is very important because it's above all measures that we are putting in the organization to make cybersecurity solid. Because we can put a lot of measures and money in cybersecurity in companies with teams, with efforts, what to do. If we don't know how many risks we have, which of the risks are very high that should be treated immediately, which from them are low, etc. We don't have control of the situation. And now we are living in a time where artificial intelligence, automation, and data analytics are very used. And that's why when we are making today's cyber risk management, we are thinking about intelligent cyber risk management that is using these powerful tools in order to make very fast cyber risk assessments, very fast cyber risk treatment. So we should use threat intelligence reports, we should use vulnerability scans. I will show now that is also important part, because as I've said before, this is initial risk assessment. Then what happens next? We have advanced scans, vulnerability scans that we can do. And we have this kind of option here. Just let me find that option here. Below risk auditing, we have vulnerability scanning. So next phase is to make these vulnerability scans, results of the vulnerability scans, to compare with the risks that are open. With this option, we can make regular vulnerability scans and use the vulnerability reports from scans in order to update this initial cyber risk assessment. As you can see, we have here network scans, we have container host scans, and we can make here scan profile. We have scan summary here. We can exclude devices from this scan. We can put some static or external devices in this scan, and after that we are making the vulnerability scan. This is thing that is also important in order to have intelligent cyber risk management in the company. So the third key takeaway from this presentation is that organizations should adopt proactive and integrated approach when they are doing cyber risk management. Just using AI power is not enough and is not secure, because AI is also not just it's technology advancement, but it's also another type of risk that should be taken into account, because we are using AI tools, but the AI tools that we are using are applications and they have also vulnerabilities. So we should also take into account when we are using AI tools to take them also into consideration when we are making cyber risk assessments. That's why humans are on the top of all this complex concept of cyber risk management. So that's why I'm saying that the strategy should be proactive and integrated approach where we are combining human and AI power. Okay, so this is all from my presentation. Now I will stop sharing this, and maybe some of you will have questions now. We can move to the questions part.
Thank you, Professor Kerry, for so much fruitful information sharing with us. And I hope
the student has gained and a lot from this, and if somebody wants to continue work with you, they will contact you if you agree with them. And this is the very fruitful topic. As we know, the cyber is being used in each and every applications, from ground to the sky, ground to the space, over the spaces, and everywhere we need the security. And there we need the firewall as well as the vulnerability. Thanks for the guiding and elaborating the things in deeply. I'm sure some of them will contact you, or if you like to do some work with us, we would like to continue with you. Thank you. Thank you on the behalf.
Thank you very much. Thank you very much for your attention. Thank you very much for your time. And have a nice day there on your excellent conference. Thank you very much.
Now the participants may go for the lunch and they can come tomorrow at 9:15 session positively. Thank you for your nice cooperations. DS4 and IT2, please come for attendance. हाँ, सबको absentees के नेम भेज दो, या तो पिक्चर भेज देना। absentees के नाम वैसे याद है यश। हाँ, absentees ही भेज दो उनको। ठीक है।